The second half of this section deals with symmetry. So just like when we studied x and y intercepts, we first learned how to identify these from a graph, and then we changed gears and developed a procedure to find the intercepts algebraically. When we work with symmetry now, it will work in a similar fashion. We will first study symmetry graphically, and then we will develop a procedure to analyze symmetry from an algebraic perspective. So let's take a look in example 3. In this example, we are going to learn how to sketch the different types of symmetry. So if you just take a glance through this particular example, what you will see is that I have two graphs here, okay? And the one on the left is kind of triangular, and then the one on the right is more of a curve. And then if you move on to the next page, you see these two graphs a second time, and then also a third time. So we've got these two graphs repeated 3 different times. And the reason is there are 3 types of symmetry. So we're going to go to each graph and sketch each type of symmetry. So let me go ahead and make a note up here of the types of symmetry. First of all, a graph can have x-axis symmetry. There's also something called y-axis symmetry. And the third type of symmetry, it is possible that a graph is symmetric about the origin. Okay, so we're going to look at the 3 types of symmetry for each of these graphs. We are going to start off with x-axis symmetry. So let's go ahead and read the directions in example 3. It says, complete each graph so that it has the type of symmetry indicated. And like I said in part A, we will be looking at x-axis symmetry. All right, so there's a hint here. This is a very visual thing. So if you are a visual learner, you might enjoy this. But if you do have trouble visualizing this, don't worry. I will also show you a method to do this without having to visualize this in your head. Okay, so the big hint here for x-axis symmetry is to imagine folding your sheet of paper along the x-axis. Where does your graph end up? Okay, so since we're doing x-axis symmetry, we're going to imagine that we're folding our sheet of paper along the x-axis. Okay, so let's start with the graph on the left. Okay, notice that there are 3 points that are called out. Okay, so I'm actually going to make a list here of old points versus new points. Now keep in mind, this is not a requirement, but it is helpful to do. Okay, you may go along as I'm doing this and decide, hey, I do want to do it this way where I'm making a list of points. Okay, again, not required, but there is a reason I'm going to chart old points versus new points. Okay, so like I said, this blue graph is our original graph. You see 3 points that are called out or emphasized. Those are the points that have the closed circles on them. So if we look at the first one, you can see where my cursor is. This point right here has coordinates -8, 3. So I'm going to go ahead and write that down, -8, 3. And then the point at the top of the triangle here, it has coordinates at -6, 7. And then the last point is on the x-axis itself. It's located at -4, 0. Okay, now please understand that these 3 points that have the circles on them, they are not the only points on the graph. The graph is made up of every point that's in blue. Okay, even the ones that don't have the big fat closed circle on it. Okay, it's just that these 3 points are the ones that are emphasized. Okay, the way that we're going to do this is we are going to move the 3 points. And then once we move the points, that will move the entire graph. Okay, so let's see how this works. Okay, to kind of visualize this, like I said, what we are doing is we are folding the sheet of paper along the x-axis. Okay, so here's your x-axis. That's where you would fold your sheet of paper. Where would the graph go? Okay, now if you think about quadrants, I'm sure you've heard of the quadrants in algebra before. The XY plane is broken up into 4 quadrants. Okay, over here, this is the first quadrant. This is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So if you kind of visualize in your mind folding this sheet of paper along the yellow line here, the x-axis, quadrant 1 is going to come down and lie on quadrant 4. Similarly, quadrant 2 is going to come down and lie on quadrant 3. Okay, now we have to be very accurate when we draw in the symmetry. Okay, we can't just draw a similar looking shape in quadrant 3. Okay, so like I said, we're going to move each individual point, okay, and get 3 new points and then connect those to get our graph. Okay, so let's see how this is done. Okay, I'm going to start with the point at negative 8, 3. Okay, so let me get a different color here. I'll use this color. Okay, since I am folding my sheet of paper along the x-axis, I am going to draw towards the x-axis. Okay, if I start with this point right here and I'm trying to figure out where it's going to go, I'm going to draw towards the x-axis and I'm going to count boxes. This point is 1, 2, 3 units above the x-axis. So when I fold my sheet of paper, it's going to go 1, 2, 3 units below the x-axis. Okay, so it's going to go to that point, negative 8, negative 3. Okay, that's where it's going to end up. Okay, all right, so now I'm going to do this again. Okay, I'm going to go to the point at negative 6, 7. I'm starting here. Fold your sheet of paper. Okay, where is this point going to go? I'm going to count boxes. It is 1, 2, 3, 4, 5, 6, 7 units above the x-axis. So when I fold the sheet of paper, it's going to go 1, 2, 3, 4, 5, 6, 7 units below the x-axis. So we are going to end up at the point negative 6, negative 7. And then lastly, I'm going to move the point that is at negative 4, 0. This one's a bit different. This point is actually on the x-axis. So it's on the yellow line. When you fold the sheet of paper on the yellow line, that point doesn't go anywhere. So it's going to stay put at negative 4, 0. Okay, so each of our 3 emphasized points have moved and have relocated somewhere else. Okay, so let me go ahead and I erased this by accident, so let me put this back right here. I'm trying to erase these kind of intermediate lines here so we can draw in the, hang on a second, let me redo this. Okay, let me erase these lines that I drew in. Okay, so we had a point right here. Okay, so we're left with these 3 new points, and that's going to shift the whole graph. All we have to do is connect the dots. Okay, now to do this correctly, okay, you're going to connect the dots with the same shape as the original graph. Okay, you need to do this from left to right. Okay, in the original graph, everything is a line. Okay, so we're going to connect everything with line segments. So go from left to right. We're first going to connect negative 8, negative 3 to the point negative 6, negative 7 with a line segment. Okay, now we're going to continue from left to right. We're now going to connect negative 6, negative 7 to the point negative 4, 0. Okay, so this green graph is going to be the x-axis symmetry that has been drawn in. Okay, so that's all you have to do. Just keep in mind, like I said, students oftentimes have no problems coming up with the new points, but they do face a problem sometimes when they connect the dots. You need to do it from left to right and retain the same shape of the graph. So for example, here everything was a line, so you connect with lines. Okay, if you have curves, you're going to connect with a curve. Okay, so let's try the next one. Okay, it's a different shape. Okay, again, you have 3 points emphasized. We're going to move those 3 dots, and the whole graph will then move. Okay, I am again going to keep track of my old points. Actually, let me put those in blue since the original graph is blue. So I'm going to keep track of my old points. I'll go ahead and list those out. This leftmost point is located at -8, 6. And then I've got a point right here on the y-axis, that's at 0, 5. And then my third point has coordinates 8, -2. Okay, so we're going to move these guys to get our 3 new points, and then we will connect the dots with the same original shape. Again, we are flipping over the x-axis. So you just want to imagine folding your sheet of paper along the x-axis, okay? And you're going to think, where does my point go? Okay? If I start off with the point at -8, 6, okay, we are folding over the x-axis. So we are going to draw towards the x-axis because that's what we're flipping over, okay? So currently we are 1, 2, 3, 4, 5, 6 units above the x-axis. So when we fold the sheet of paper, we're going to go 1, 2, 3, 4, 5, 6 units below. So we're going to end up at -8, -6. So that will be the new point here. All right, so now let's move on to the point at 0, 5. Okay, draw towards the x-axis. Count boxes. We are 1, 2, 3, 4, 5 units above the yellow line or above the x-axis. So when we fold the sheet of paper, we're going to go 1, 2, 3, 4, 5 units below. So we're going to end up here at 0, -5. And then lastly, if we look at 8, -2, okay, this point's actually below the x-axis. So when we count boxes, we are currently 2 units below the x-axis. So when we flip, we've got to go 1, 2 units above. Okay, so we're going to end up at the point 8, +2. Okay. All right, so now we're going to connect the dots. I'm going to erase these intermediate lines. Okay, just so I can have a cleaner looking picture here and see what I'm doing. Okay, so you're going to go from left to right. Okay, the original curve is not a line, it is more of a curve. So you're just going to have to connect it with that same basic shape. Okay, this may take me a couple of times to draw accurately. So this first piece we're going to connect from left to right here, and then from left to right here. And there you go. That's the x-axis symmetry. Okay, for both of these graphs, okay, if you fold your sheet of paper along the yellow line, the blue graph is going to lie directly on top of the green graph. Okay, all right, so that is how x-axis symmetry works. Okay, now there was a reason I kept track of old points versus new. Okay, so let's take a look at our findings here. Okay, if you examine the old points versus the new points, look at what happens. Okay, so let's start with the graph on the left, the triangular graph. Okay, if you go from -8, 3 to -8, -3, notice your x coordinate does not change, but the y value changed sign. Okay, and you will see that same idea happening with the rest of the points. Okay, if you examine these points, okay, old versus new, all of the x coordinates do not change. -8, -8, -6, -6, -4, -4. But the y values change sign. You go from +3 to -3. You go from +7 to -7. 0 doesn't have a sign, so it doesn't matter there. But if you go over here, you see the same thing. If you're comparing old versus new, your x coordinates do not change. Okay, you've got -8, -8, 0, 0, 8, 8. The y coordinates, however, change sign. We go from +6 to -6. We go from +5 to -5. And then finally, we go from -2 to +2. Okay, so we are going to go ahead and write this down as an observation. Okay, so I'm going to kind of shorthand this. Okay, if we are dealing with x-axis symmetry, what happens is if we start with a point, okay, an arbitrary point with coordinates x, y, where is that point going to get sent? Well, the x value is going to stay the same, but the y value is going to change sign. Okay, do not interpret this negative y as meaning that the y value must become negative. What this negative sign in front of the y means is that y is going to change sign. Okay, so let me translate this. Okay, this means that x stays the same, but y changes sign. Okay, so that's what happens with x-axis symmetry. Okay, if you jump ahead to page 6, to the top of page 6, we are going to go ahead and summarize this. I'll write this in one place for all the different types of symmetry. It says notice from example 3, that's what we're currently on. The first bullet point talks about x-axis symmetry. If a graph has x-axis symmetry, then for every point x, y on the graph, that's going to mean that that point is going to get sent to x negative y. Okay, so again, I'll write right here. This means that x stays the same and your y coordinate changes sign. Okay, so that's how we could have handled this. You know, that's how you handle this when you actually physically draw the x-axis symmetry. If you are looking at a graph and trying to determine the type of symmetry it has, and we're actually going to do that in example 4, okay, you can use this statement. Okay, if a graph does have x-axis symmetry, if you start with a generic point x, y, if that point is on the graph, then if the graph does have x-axis symmetry, that means the point x negative y will also be on the graph. Okay, so let's try y-axis symmetry now.